Algebra is the section of mathematics that deals with variables, as opposed to placeholders. A variable is so called because it represents any one real number, the value of which is unknown. It is sometimes referred to as the unknown. In algebra, variables are normally represented by alphabetical letters. Consider the addition of a certain number, contained in a placeholder, and 3, which equals 7. In previous grades, this was interpreted as 3 plus what number equals 7. This number represented by the placeholder is quite clearly 4, since 3 plus 4 equals 7. In algebra, the above equation is commonly written as 3 plus x equals 7. The letter x is used instead of a placeholder, and is called a variable. Variables in algebra are generally represented by alphabet letters. So, we could have just as easily used the letter y, z, p, q, etc., instead of x, to represent the placeholder. Before getting to variables and operations, consider the 4 mathematical operations as they apply to simple problems. The sum of 7 and 3, as a number sentence, equals 7 plus 3. The difference between 7 and 3 is written as 7 minus 3. The product of 7 and 3 is 7 times 3. And the quotient when 7 is divided by 3 is written as 7 divided by 3. When it comes to replacing one of the numbers, say 3, with a variable such as p, then the sum of 7 and p is given as 7 plus p. At this point it is important to note that p, being a variable, represents any value, and not necessarily 3. We can therefore not add 7 to p and get another value, because we have no idea of knowing what the value of p is. The difference between 7 and p is given as 7 minus p. The product of 7 and p is given by 7 times p, or more simply 7p. And the quotient when 7 is divided by p by 7 divided by p. It is also important to note that, in this division, p cannot be 0, since division by 0 is undefined. It is important to be able to translate a verbal expression into a number sentence. The terms sum, more, add, plus, and increase, in mathematical terms, all imply the operation addition. The terms difference, less, subtract, minus, and decrease, all imply the operation subtraction. The terms product of multiply and times all imply the operation multiplication. And the terms quotient, divide, and divided by all imply the operation division. Let's look at a few examples. The sum of 3 and a number is given by 3 plus x. 7 more than a number is given by p plus 7. A number increased by 12 is given by y plus 12. 17 less than a number is given by x minus 17. The difference between 9 and a number is given by 9 minus x. And a number decreased by 4 is given by k minus 4. Note that it doesn't matter which letter you choose to represent the certain number. What is important though, is how the number sentence is constructed from the verbal expression. The product of 5 and a number is given by 5x. 7 times a number is given by 7p. The quotient when 21 is divided by a number is given by 21 over x. A number increased by another number is given by x plus y. Note that, since the two numbers are different, we cannot use the same variable for each number. Of course, you can choose whichever 2 letters, or variables you wish. A number decreased by twice another number is given by k minus 2p. Let's move on to the addition and subtraction of variables. Consider 7 plus 7 plus 7 plus 7 plus 7, which equals 5 times 7, or 35. Substituting 7 for a variable such as p, gives us p plus p plus p plus p plus p, which equals 5p. Note that, since we do not know the value of p, we do not know the value of 5p. So this is as simplified as the multiplication of 5 and p gets. Since addition and multiplication are both commutative operations, p plus 5 equals p. And p times 5 equals 5 times p. However, the same cannot be said for subtraction and division. In other words, p minus 5 does not equal 5 minus p, unless p equals 5. And similarly, p divided by 5 does not equal 5 divided by p, unless p equals 5.